It's another Earth Science video. This is Norris Teaches Science with me, Mr. Norris. Today, in this Earth Science video, we're going to talk about volcanic eruptions. So by the end of this video, you should be able to say to yourself, I can discuss the factors that contribute to an eruption of a volcano. So before we talk about that, I mentioned the terms magma and lava, and they both mean molten rock, but they are different because they indicate where the molten rock is. Magma is molten rock that is under the surface of the earth. It means it has not been exposed to air on the surface. Lava is molten rock on the surface of the earth. They're still both molten rock, but you have to remember which version of the type of molten rock you're saying. Now, when we also talk about magma or lava, we need to talk about something called viscosity. And this viscosity's definition is a substance resistance to flow. So if a substance has a high viscosity, it has slow movement. While if it has a low viscosity, it has fast movement. Think of it like this. You have an inclined ramp that at the start you place water and you place honey. Which one's going to reach the bottom first? It's going to be the water. Water has a low viscosity while honey has a higher viscosity. Now, high viscosities, when you talk about magma, mean violent eruptions. And so, remember we talked about stratovolcanoes having very violent, explosive eruptions. That's because most times their magma is high in viscosity. Now, factors that affect eruptions are magma composition, magma temperature, and the amount of dissolved gases that are present. So, magma composition. The composition of magma is based off the silica content, or the amount of silicon, the element silicon, that is in the magma. More silica equals greater viscosity. So that means, if we think back to when we talk about viscosity, remember high viscosity equals higher, more violent eruptions. So if the magma has a lot of silica in it, it's going to have a very explosive eruption as well, because they are all correlate to each other. Magma temperature, hotter the magma, more fluid, less viscosity. So low temperatures equals more explosive eruptions as well. Dissolved gases, there's a lot of dissolved gases that are in the magma chamber or in the magma tube. You can have water vapor, which is HO2 in its gas form, carbon dioxide. There's other toxic gases in there. And the more gases there are, the more violent the eruption. Think of it like shaking up a soda bottle and then trying to open it, it's going to explode everywhere. You just created kind of more gases in there. Versus if you let the soda bottle sit, it's not going to explode everywhere when you open it. Now, when a volcanic erupts, there are materials that are sent out. You got your lava flow, you have your gases come out, your pyroclastic material comes out, a pyroclastic flow could come, and something called a lahar. We're going to talk about them. So lava flows, usually when I think of lava flows, I think of, just things just engulfing whatever it comes in contact with. But we can actually look at lava flows, and we kind of have two names for them. They come from more Hawaiian names, words. You have the pahoho. I'm guessing that's how you say it. That's how I would say it, pahoho. This is lava flows that resemble a twisted braids and rope. That's what you see in this top picture up here. This is more of a pahoho. And the aa is a lava flow that has a surface that is rough, jagged blocks with dangerous sharp edges and spiny projections. Gases, um, remember, gases are released during the eruption. The amount of gas also determines how violent the eruption is. About 70% of all the gas will be water vapor. 15% will be about carbon dioxide. 5% about nitrogen. 5% sulfur, and then there's other variable gases that can come out. Um, Now, some of this stuff is these gases do seep out ahead of time, and like if there's not some of the sulfur can seep out of like say a side vent, just the gas, and if that side vent is near like a water body, it can turn that water body into like an acid lake. So if you jumped in, you would be dissolved. So gases do play a factor in before and after and during an eruption. Pyroclastic materials, these are fragments ejected during the eruption. They can be from very fine to several tons. You can see some pictures over here of different types of pyroclastic materials. You got ash that comes out. You have cinders or lalabili. And you also have like these things called volcanic bombs. They're like big, giant rocks. I talked about pyroclastic flow in the last video on volcanoes, but you can kind of see a pyroclastic flow here. It consists of hot gases, glowing ash, and large rock fragments. And what it does, it raises down a steep slope. These are most associated with those stratovolcanoes or composite volcanoes, and they just destroy everything in their path. Um, Most of you guys probably have heard of Pompeii being destroyed by Vesuvius. Pompeii was destroyed by a pyroclastic flow. Then you have lahars. These are a type of mud flow. What happens is the volcanic debris is saturated with water, and it rushes down a slope, kind of like what you see here, um, and it kind of just takes everything with it. Now, some signs that a volcano is about to erupt. There are some signs. First off, there's sometimes small earthquakes right before an eruption. You also have swelling of the volcano surface. So geologists will actually monitor from a distance using scientific instruments the size of the volcano, and sometimes they can see a little bulge form on the side of the volcano, means it could be about to erupt. They call it ground deformation. There's sometimes emission of heat or gases from vents. You start to see more gases and stuff come out of the vents. You can also have acidification of the land and acidification of the water, and since things have to be in balance in there. You can start seeing dead animals come up that was usually in that area. So these are just some signs of volcanic eruption. But this is a little bit about how a volcano erupts, stuff that comes out of it, and everything like that. I really hope you learned something today. And this is Mr. Norris, and he's signing out of this video.